This is John Black, super chemist, showing you how to get anhydrous ethanol.
I already did a video where I actually take some vodka, I azeotrope distill it, and then I use molecular sieves to dry it out so it's totally anhydrous. But this video is just going over several different methods of ways you could do it.
Here's the formulas. Here's how some people, like if you have ethanol, C the ET. If you have methanol, you put MEOH. The OH is for the alcohol. Some facts about it. Boiling point. Dipole moment. I think that D stands for deby. I didn't look up what the units were. I'm guessing it's dBys. Keep in mind, this is flammable like pretty much everything you distill. I want you to realize, because a lot of people don't understand, inflammable and flammable are the same word. They're synonyms. They mean the same exact thing. The first thing I want to go into is how I do it, and I'm going to tell you a mistake that I've been making in a couple of my videos. Well, there it is. That's what I usually get, just some vodka, regular. Obviously, if you can get better alcohol, with a higher proof or whatever. This is just what I had laying around, so I put it on the video. What I do, I get vodka because it's the cleanest alcohol you can get. Don't be getting those colored whiskey or something, rum or something. Get the clear vodka. You want the highest proof you can get. I mean, if you can get higher than 100 proof, get higher than 100 proof. I fractionally distill it once. Now, when you fractionally distill, the difference between the temperature of a azeotrope and the say 90% instead of 95 or whatever, it's pretty much the same boiling point. You're not going to be able to separate those without like 20,000 distillations. All right. So even if you use a fractional distillation, you are not going to get no 95.6868%. That is not possible. Okay, unless your fractional column is 10 feet tall, you know what I mean? But you should get about 90%. Here's what, let's say you have a liter of ethanol that's an azeotrope, okay? That means the percentage mass is 95.7%, okay? 4.3% is water. So if I have 1,000 milliliters, I multiply that by the density so that I can get grams, right? How many grams does that weigh? That weighs 789 grams, 1 liter, okay? And if 4% or 4.3% is water, I multiply 0.0431 times the weight, and I get how much weight of water there is. There'd be 34 grams. Now, we already discussed Epsom salt, and we know that whatever you put in is how much you're going to absorb in water. So I'd need to put in about 34 grams to get out this 34 grams of water, okay? I'd put in 34 grams of Epsom salt, magnesium sulfate, and then when it came out, it would weigh 34 plus 34, you know what I mean, or approximate, because it would soak up all the water. But keep in mind now, like I said, unless you're going to distill this 100 million times, you're never going to get it to 95.6%. So you're most likely going to get it to about 90%. So I figured it out over here. Here's the weight of this 1 liter, right? What's 10% of it? 79 grams. So that's how much water you probably have in there if you fractionally distill it, which means you're going to have to put in 79 grams of magnesium sulfate. When you put this magnesium sulfate in, it's powder, right? But when it hits any water molecules, it will incorporate that into and try to make a crystal lattice, and that's and you'll see it because your stuff will clump up into crystals basically. Instead of it being powder that slides around, it'll clump up into bigger pieces. When it stops clumping up, that means there's no more water to collect. And when you do this, you don't just do it 15 minutes later. If you want really anhydrous alcohol, you're going to have to go past doing it for 15 minutes. You're going to have to store it for like 24, 48 hours to make sure that you get all the water out. You know what I mean? If you just want it basically dry, yeah, just throw some in for 15 minutes, let it stir. It's the last couple grains of water that's really hard to get out of there. You know what I mean? It depends on how anhydrous you want it. If it's really sensitive to water, you might want to let it sit there for a day or two. I bought molecular sieves, so I'm going to use them this year. You can also use those. I think most molecular sieves, if they're good, they'll absorb 20% of their weight in water. So throw them in, and like I said, if you want it dry, bone dry, you're going to have to leave those molecular sieves in for a couple days, at least 24 hours. Keep in mind that when you dry this with the Epsom salt or magnesium sulfate, you will have a grain or two, very, 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 very little magnesium sulfate dissolve in the ethanol. So if you don't care about that, but you want it dry, yeah, you'd have to leave that in there for at least a couple of days to dry it. But if you're going to distill it afterwards, because you really want it pure, you don't want no magnesium sulfate in there, not even one little molecule. You're going to distill it after you dry it. So you could just dry it for 15 minutes, 20 minutes, you know what I mean? Maybe even an hour stirring. And then you're going to distill it anyway. You're going to filter that stuff out and distill it. When you distill it, just throw away the first, little bit of alcohol that comes over, because that's the azeotrope. Once you get the azeotrope out of there, the rest of it's going to be pure. The first few milliliters or whatever of alcohol that comes over, because the water's going to come over with it first, right? Once it's out of there, then you can change out your receiving flask and collect your pure alcohol and leaving the magnesium sulfate in the pot. Let's go into a couple different ways you can make this stuff. There's fermentation. I personally don't like it. I've tried it. I mean, you're basically making beer, not hardcore liquor. You get nothing out of it. But you can try it. It's a good experiment. Fractional freezing. This works on a few things. I think H2O2, hydrogen peroxide, you can do this with. Rubbing alcohol, I think. But basically, that's how, if you've ever heard of Applejack, that's what they do to make Applejack. They get basically beer, they put it in the freezer. Basically, this is like fractional distillation, but you're going in reverse. You're freezing stuff out instead of distilling it out. And this could work like if you put hydrogen peroxide in the freezer, you freeze it up, it'll freeze the water before the hydrogen peroxide. So what you have left is pretty pure hydrogen peroxide. Basically, you've ever heard of Applejack. That's basically what they're doing with Applejack to make it more pure beer. You know what I mean? More alcohol in your beer. I don't suggest that either. But it's a good experiment. I'd like to try it. I've never tried it. Another way, which I've never tried, is salting it out. Now, isopropyl alcohol, rubbing alcohol, you can salt out pretty easy. You just use sodium chloride or whatever. But ethanol is a little more tough. Their example here is potassium carbonate. You put it in there, make a saturated solution in the water, and it will form two layers. And then you can pretty much have your layer of ethanol that's pretty much pure. You distill it, and it's definitely pure after that. Another method is in trainers, using ternary azeotropes. And that's just an azeotrope. It has three constituents instead of two. You know what I mean? Instead of ethanol and water, you'll have three. And the thing is these are the three examples they gave me: benzene, cyclohexane, and heptane. You basically put, say, the benzene into the alcohol mixture. Let's say I got alcohol, water, and benzene. Now it'll form a ternary azeotrope between all three of them that boils lower than the azeotrope of just the alcohol and water. That way you can get the water out faster and leave behind, relatively pure alcohol. Now, just to show you how things are mixed up on the internet, I've heard of this method a million times, and benzene, all three of these examples is in trainers. So I know they work. I've read them in 50 million books, okay? But when I put it into a program that shows ternary azeotropes, I will plug in all three of these individually with water and ethanol. You know what I mean? Benzene, water, ethanol. And I did cyclohexane and water and ethanol, and then heptane. And let me tell you, they say that none of them form a ternary azeotrope. So which is it? They either form it or they don't. You know what I mean? Now, I believe that they do form it. But like I said, things are so contradictory, and that's why I want to get to the last method, which is pressure swing distillation. Now, I've said a couple times that you can jump over the azeotrope by changing the pressure to a vacuum. And I've also said that you can change it to a high pressure. Okay. The reason is because every time I read about the individual azeotrope of ethanol and water, it always says that you use a vacuum and that you can see right here, azeotrope vanishes below 30 degrees Celsius. Azeotrope vanishes below 70 torr. So basically you take it down to 70 torr and you will take out the azeotrope and you can just distill out your alcohol pure. You know what I mean? But when I read, and I just started reading about not individual azeotropes, but all azeotropes, when I read books like that, then it says the opposite way. It says that you put pressure on when you have a minimum boiling azeotrope, that you put pressure on any azeotrope, doesn't matter what it is they're saying, that you will basically think of it this way. If you have a higher pressure rate, you have the water is hard to boil and the alcohol is the lower boiling, right? So if you put pressure on it, you can think of it as the higher boiling point is going to be suppressed more because it's going to get closer to that point where it won't evaporate at all. You know what I mean? Whereas the alcohol has a lot further way to go because it's so volatile. You know what I mean? No matter, you got to really put pressure on it. So you're not suppressing them at the same rate. You know what I mean? A higher boiling point will be uh, compound will be suppressed even more, a bigger percentage than a low boiling component. But that isn't the case when I read about individual, because this one has that. You have the low boiling ethanol and the high boiling uh, alcohol. Some books say, I mean, all books actually say that you just put the pressure, you put a vacuum on it. I don't understand. They're contradicting. I understand Holt's law and vapor liquid diagrams. I mean, when it comes to, but when you start to get the azeotrope and you do the pressure swing thing, I am getting so many contradictory things being said. And there's only two schools. One is saying that all positive boiling azeotropes, you put pressure on it and you're suppressing the higher boiling point component more than you are the low boiling component. But like I said, does anyone know what the deal is? And then I have a third one where they're saying it has nothing to do with uh, the boiling point of each component. It has to do with other things. Um, I don't know. Anyways, I just wanted to let everyone know I do not know about pressure swing distillation. So the couple times where I brought it up, I don't know. I'm getting too many contradictory things being said. Well, let's dissect this word ethanol. Here's a picture of it. You got your two hydrogens, three hydrogens, OH. Why is it called ethanol? Well, let's take a look. You got how many carbons? One, two. Two carbons is ethane, right? That's the hydrocarbon ethane. If there was no functional groups, that'd be called ethane. But we do have one functional group. It's an alcohol. And OH means alcohol. Now I want you to look at the first part of ethane and the last part of alcohol. Now I want you to put them together. What do you got? You got ethanol. That's why it's called ethanol. And this is a primary alcohol. Why? Because the OH is attached to a primary carbon, meaning the carbon is at the end. It's only primary means one, right? It's number one. So how many carbons is this attached to? One carbon. So it must be primary. So if this carbon's primary, this alcohol is primary. Primary alcohol. Have a great day, and always remember, science is great.